Let us differentiate 6e to the 7y. Now this is implicit because you're supposed to find dy by dx, alright? Now, what you have is a function of a function here. So, what you have is a function 7y, and then another function of it, which is 6e to that other function. Now remember the chain rule. The inside function is 7y, and when you differentiate 7y, you get 7. That's multiplied by the outside function, which is 6e to the 7y. This is going to be like 6 times e to the 7y. Now when you differentiate e, for example, when you differentiate e to the x, what you get was e to the x when you differentiate with respect to x. Now this function, e to the 7y, what you will get is 7e to the 7y. Alright? Oh, I'm sorry. Not 7 again. I already put the 7 there. This is already done. What you will get is e to the 7y. Let me erase this and do that part again. So, this is going to be e to the 7y. So it's really 7 times 6e to the 7y you're going to have, which is equal to 42e to the 7y. Right? Now, here is like saying you have y equal e to the 8x, and then you say that u is equal to 8x and y is equal to e to the u, and you say dy by dx equals du by dx. When you differentiate this, you would get 8 times dy by du, which is e to the u. So it's 8e to the u. Notice the 8 comes down and multiply the e to the u. But u was 8x, so it's 8e to the 8x, right? In the same way, the 7 comes in front, and you multiply 7 times 6e to the, and then it's 7y. Now, looking at it again, suppose it was, say, C, D, F. F is equal to 6e to the 7y. Let's go through this part slowly. What you would have is df by dy. You want to find df by dy. If you say, let u be equal to 6e to the 7y, then f would be equal to, and what you would have is f would be 6. Oh, let me do that part again. U wouldn't be equal to everything. My mistake there. U would be 7y. Let u equal 7y. Just like how you said let u equal 8x here, you let u be equal to 7y here. You see that? Then f would be equal to what? It would be equal to 6e to the u. And then here you would have du by dy equal, because you want to differentiate u with respect to y, du by dy would be 7, and df by du would be 6e to the u. Now df by dy would be the same as df by du times du by dy. And you notice du would cancel du, so it's df by dy. Just building the argument as to why it works, right? So here, what you would have is df by du, and this is df by du, and that would be 6e to the u times du by dy, and du by dy is 7. Now 7 by 6 is 42e to the u, but what is u? U is 7y. So what you would say is 7y. So you see it's 42e to the 7y. You see why it works? So here, just like how you would have y equal e to the 8x, what you would end up with is 8e to the 8x, because you say let u equal 8x, y equal e to the u. dy by dx would be dy by du, which is e to the u, times du by dx, which is 8. So it's 8e to the u, which is the same as 8e to the 8x. Same argument here. We can't use x and y again here. We already have y. We could use x, but I choose to use f. F equals 6e to the 7y. Now df by dy, that's what we want. So let u be the 7y, the power, and then f would be 6e to that, 6e to the u, right? And then when you differentiate u equals 7y, du by dy would be 7. As for f equals 6e to the u, the f by du would be 6e to the u, just the same, right? And then what we would have is the f by du, this 6e to the u, times the u by dy by 7. 7 by 6, 42e to the u, but u is 7y, so it's 42e to the 7y. Now up here, the same argument applies. 6e to the 7y, you're finding dy by dx. It's a chain rule that applies here. So it's, you bring down the 7 and multiply. So you have 7 times 6 times e to the 7y, because if you consider breaking it up into u, this would be u, the inside function. U would be 7y. And then the outside function would be 6e to the this. So when you differentiate e to the this, you get back e to the this. E to whatever it is. But you have to multiply by 7, because when you differentiate the inside function, this, you're going to get 7. And you multiply this by 7 because it's the derivative of the inside function times the derivative of the outside function. The derivative of the inside function with respect to u, if you call of the inside function by dy, it is the derivative of the inside function by dy with respect to y. U equals 7y, you're finding the derivative of u with respect to y, times the derivative of the outside function with respect to the inside function, which we call u. So it's the outside function with respect to u. So df by du equals 6u. When we say df by du, it's just that we call this f, and then what we're finding is df by d of 7y. But 7y is what we call u. Right? If you think about it carefully, you'll see that the argument surrounding the use of the chain rule, it does apply. It's what works here. But if you practice these and do many of them, you would be able to pick up that skill of just looking at it, and within 2-3 seconds you can tell what the answer is. You must multiply by the 7, bring the 7 in front, multiply it, and get 7 by 6, e to the 7y. Alright? So, we'll do some more implicit differentiation in other videos. So I will see you there.